think that was a polite way of saying I've been in the field for over 30 years. Thank you very much to AWE for inviting me here and allowing me to speak. I wanted to, my organization, my team within AMD is chartered with responsibility around our ecosystem enablement, but very specifically, one of the technology areas is immersion. Immersive technologies, XR. So rather than VR, we focus, or we think of this as a full AR VR ecosystem. To that end, what I wanted to talk about today is a solution, a technology solution that we've integrated into and recently released in our graphics driver called Relive, specifically Relive VR, and I'll get into what is involved with that. But Relive as a technology solution is a streaming capability. You guys probably know graphics, the discrete graphics industry is driven in large part by gaming, certainly by cloud solutions, but in the gaming space, there's a lot of desire, a lot of need for streaming, whether it's streaming in a Twitch form, or in our case, one of the solutions we wanted to implement with Relive was the ability to stream to content from your gaming environment to your mobile phone. So, but the benefit of that same technology is an extension that we've implemented for VR specifically, or VR or AR type applications. Before I get into the details of Relive, I want to give just a kind of a brief background of AMD. AMD as a company has been around. Actually, this is our 50th anniversary this year, so we're having a lot of company celebrations around that. Over the years, we've had many firsts. Most recently, I'll point out that we have we are the first to achieve 7 nanometer production silicon. And we launched some products early this year. We've got more coming. But lithographies themselves are becoming more and more difficult to achieve. So 7 nanometers allows us to get to lower power, higher performance. But over the years, we've had some significant breakthroughs, such as integrating GPUs and CPUs together. So as the only company in the industry, in the PC industry, that has both CPU and GPU capabilities, we felt that was a critical step forward. You know, what we call APUs, the ability to integrate this and have a more cohesive solution. From that stage, from that time frame rather, what we've been driving is this need for this opportunity rather to optimize the interaction, optimize data paths, optimize performance of solutions at a very low level, what we call close to the metal, silicon. With that in mind, and I guess the other point I should have made there is we also are the exclusive supplier within the graphics solution into the console industry, have been for many years. We're exclusive supplier for Apple's graphics solutions. So we have a great deal of background and experience and capability. And when we look at the industry, we think of it in terms of this immersive and instinctive opportunity. Immersive, I think, is very clear to most people. Everything you see here, more or less, is built on the idea of and the need for immersion. Having graphics capability that pulls you in, whether that graphics capability is for the PC gaming, for VR, for AR, but also the ability to compute in the cloud, to compute different types of big data analysis. The next stage, in my mind, the next stage beyond this is that instinctive generation. And that's where artificial intelligence, machine learning type implementations become mainstream. Now, don't get me wrong, others have already mentioned that AI, machine learning type applications are actually in mass production already. You know, many of them are hidden in ways that we don't think of them that way. But at some level, they're going to become more commonplace, more integrated into things that we think of today as sci-fi, But in reality, it's just a matter of achieving optimization, achieving a solution set that people want, you know, the critical killer app, killer opportunity. So how do we transform people's lives using this type of technology, either current technologies or future development, future technologies? When we think about the various industry trends, again, compute capabilities, CPU, GPU capabilities are not bound by our desktop or our notebook PCs, right? There's a tremendous amount of growth in the cloud, in data centers. What's about to emerge, what's pending, if you will, is a new area called edge compute with 5G, cellular 5G type networks about to deploy around the world. Initially in Asia, I would say. Certainly there are trials going on in the US. There are different trials around the world. But there's a great deal of growth that's about to happen in terms of compute capability, not in the cloud, but much closer to the user in the edge. By having this compute capability there, how do you take advantage of it? How do the carriers take advantage of it? How do users take advantage or benefit from that? That is one of the things that we're looking at as we look forward at these megatrends, these directions for the industry. Some of the stuff is very, very interesting, but the question is, how do we put this in front of and leverage this with consumers? And how do we take that technology in a number of, and I'm just listing a few vertical markets, but different vertical markets, all of these markets are served by either compute or GPU compute or CPU compute capabilities, but they're all largely independent verticals. And again, there's this underlying infrastructure opportunity to connect all these, to bring all these together. And a lot of that actually is a result of what's happening at this conference, of what's happening in this industry, of augmented reality, of XR as we think of it. How do we then take advantage of and leverage, security capabilities within the medical industry, or how do we tie these different things together in a lower level infrastructure? So, with that in mind, let me switch over to introducing our Relive solution. So again, Relive is how many here, by the way, let me ask a quick question. How many of you actually, either yourselves or your kids, perhaps more your kids, do gaming, PC-based gaming at home? Okay, so how many of you actually have discrete graphics cards in your computer? All right, okay, even more than do gaming. So you all understand that with discrete graphics comes a level of performance, a level of capability. And so as we look at this streaming capability, again, it was initially designed for the purpose of traditional flat screen gamers. But the more we got into it, the more we realized that it's really very, very easily extendable into VR. Now here's the trick, if you will. Why? Why would we do this? And by the way, I say VR. Our vision of all this is that this is also equally valuable to, or can be equally valuable to, an AR ecosystem as well. The question is why? You wouldn't extend this into a tethered VR headset, because the tethered VR headset is already physically connected to your PC. So what exactly is it that we're trying to do, and the purpose of this initiative? Well, wireless, very simple. In the VR world, the high-quality headsets, the tethered headsets, they're where they are taking off, largely, I would say, in the professional world. They're still the single largest complaint that we hear, that headset manufacturers hear, is the cable, the wire. Because the moment you touch it, the moment it pulls on your head, you step on the cable, you lose immersion. You lose the belief system that you've developed in the past few seconds. How do you eliminate that? Many of the AR systems don't necessarily have that, but they do have a different problem. And that problem is, well, let me continue on the VR for just a moment. So So there's a solution that the VR headset manufacturers have been developing to overcome that problem, and that is what? These all-in-ones, right? Everything is computed in the headset. It's a smartphone, if you will, type architecture, all captured in your headset. That's a nice solution. There's no wires. And as long as you've got inside-out tracking, as long as you've got proper registration, 6DoF type capabilities, you're good. Problem is, your compute capability is limited by whatever is in the headset. And for many, many applications, that's fine. For many applications, it simply won't do the job. So that's where, between that and AR systems that are of a similar design architecture, there's this opportunity to take this massive compute capability that we have already, whether it's our home PC gaming machine, or it could be something in the cloud. How do we take that compute capability, those games, those capabilities, those design automation tool sets, and put them into, enable them over a headset, an all-in-one headset or an AR type implementation? And the answer is, quite simply, wireless. Ideally, what we've actually implemented is essentially a free solution. So rather than looking at WiGig, WiGig's a good technology. If you're not familiar with what it is, Google it. but WiGig is not here yet, not truly in volume, and it's expensive to implement. It's expensive in terms of power. Wi-Fi, not one person in here has, everyone, sorry, in here has Wi-Fi already on you. Everyone in here, I assume, has a phone. Wi-Fi is free. It's everywhere. It's even stock kind of implementation in desktop PCs these days because so many people use it at home. So leveraging Wi-Fi, traditional Wi-Fi pipe or router, all we're doing is taking this implementation, this content, traditional game, traditional tool, architectural tool, pro tool, whatever, and through its render engine, we capture the output of that. Again, because we own the graphics driver, because we own the low-level capability, we trap straight out of the buffer, and we have a very highly efficient, low-latency architecture where we can, in real time, capture, encode, packetize, stream, all of that content over to this headset. And then in the headset, there's an application that does some of the simple operations that are needed for obviously for decoding, but also for optics correction and for time warping and so forth. Now, and then the closed loop, of course, is all of the head motion, head movement data has to be very low latency, has to be provided back to the PC so we can compute next frames. This whole process has to be done at the headset rate, at the frame rate of the headset. Most of those are between 72 to 90 frames per second, depending on the headset that you're looking at. So the task here that the function that we've implemented does just that. To the extent that there is always going to be latency involved, we do our best to mask that, and there are techniques that we can leverage in this world of digital rendering, where we can mask different types of motion artifacts. But essentially, the implementation wirelessly is virtually identical to a wired implementation. And again, it's free. So this is somebody playing a game at a recent conference, and obviously in fast motion. But what you'll notice, if you can pay close attention to his hand movements and the screen on the table behind him, everything's matched up. Now, if you're in there, it's much more believable, of course, but this PC on the desk is what's actually rendering the game. So it's rendering it with no knowledge that it's doing it wirelessly. It's just running it, in this case, it's a traditional Steam VR game, and running it through our driver stack. So this headset, this is the HTC Focus Plus, and so all that data is being run traditionally, no changes from a software standpoint. Again, that was a criteria we had, was there could be no impact to the ISVs, to the software community, if possible. So by using standard SDKs, standard APIs, we're able to take off-the-shelf games, no change to them, and simply render them out to a remote device. The benefit, of course, with Wi-Fi, I mean, there's a lot of benefits here, of course, because it's the way we've implemented it at a close to the metal kind of architecture. We have very low latency. But we also, by using Wi-Fi, You can have a very large area. You can have multiple users in there because Wi-Fi has many channels. In this instance, what we were rendering, it's flexible, but what you were just watching, we have it set at a rendering rate of about 50 megabits per user, or per stream. Now, you can set it at different quality levels if you want. But there's no blind spots, there's no hidden environments, you know, everything just runs properly. So, is it just for gaming? The answer is no. So this is actually a pro tool. So we work very closely with all of the pro community, you know, design automation, architectural, media and entertainment industries, and integrate their tools into this same type of environment. With the, again, the objective being that the feedback they've been giving us over time is we want VR, we want AR, we want either more compute capability or we want no wires. And they're struggling with the fact that they don't have that. So this is an example of a virtual virtual camera architecture.